Hi everyone. Today I am going to take softening of water. Why it is important? Water is one of the most useful things in our daily life. We are using water for so many purposes like drinking, cooking and washing clothes, bathing and also for so many industrial works. Without water, we simply cannot imagine our life. But nowadays, because of so much pollution happening everywhere, the water we are getting is not pure and clean like before. It is containing so many types of impurities and harmful substances inside it. Now, uh, when we are talking about impurities in water, there are two main types of problems we are facing. First one is the general impurities and pollutants that are coming into the water because of pollution, like uh, chemicals, bacteria, dirt, and all those things. Second one is something called hardness of water. This hardness problem is a very common thing, especially in India, and it is causing so many headaches for both common people and also for industries. So, what is this hardness actually? Basically, when water is traveling through uh, soil and rocks, it is picking up certain minerals and salts, mainly calcium and magnesium salts. These salts are into dissolving into the water and they are making the water hard, but making hard. You cannot see them with your naked eyes, but they are very much present inside the water. Now, why is hard water a problem? See, when we are using hot water for drinking purpose regularly, it is not good for our health. It can cause kidney stone problems, digestive issues, and other health related problems over a long period of time. Not only that, when we are trying to use hot water for bathing, the soap is not giving a proper lather. When we are using more and more soap, but still not getting good foam, this is this is because of hardness. This is because of hardness only. Same thing with washing clothes also. The clothes are not getting cleaned properly and they are looking dull and rough. Now, coming to industries, the problem is even more serious there. In industries, water is used in boilers, mm, cooling towers, pipelines, and so many equipments. When hot water is heated in boilers, the calcium and magnesium salts are getting deposited on the inner walls of the boiler as a hard crust. This is called scale formation. Because of this scale, the boiler is not heating properly. More fuel is getting wasted, and slowly, the equipment is getting damaged. Repairing and replacing this industrial equipment is uh, costly. Replacing the industrial equipment is costing so much money. So, hard water literally creating financial loss for the industries. Because of all these reasons, the health problem, soap wastage, equipment damage, and financial loss, it is becoming very, very important to remove the hardness of from water before using it. The process of removing hardness from water is what we are calling softening of water. By doing water softening, we can make the water safe and suitable for both domestic and industrial use. It is very necessary and important process in today's world. This water softening This water softening can be done in two ways. One is the external treatment. External treatment or external process. And second one is the internal process. There are two processes. By using this process only, the hardness present in the water can be removed. In that way only, the hard water is converted to soft water. Okay, ma? And then, first of all, we'll discuss about external treatment. What is external treatment? External treatment means the water is treated externally before the water is feeding into the boiler or before the water is supplied into the boiler. That is called external treatment. In the external treatment, it consists of, there are three processes in the external treatment. One is the lime soda process. The external treatment, it consists of three processes. One is the lime soda process. Lime soda process. And second one is the zeolite process. And third one is the ion exchange method. There are three methods in the external treatment. Now we'll discuss one by one. First one is the lime soda process. Lime soda process, here lime soda, that is the formula for lime soda, that is Na2 CO3. This is the formula for lime soda. This lime soda is treated with hard water. The hardness causing impurities, the hardness causing salts present in that water is considered to be a hard water. The hardness causing salts like calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, calcium bicarbonate, and magnesium bicarbonate, these are all the hardness causing substances. These substances present in the water. All these substances are soluble substances in water. The soluble substances in water, the soluble types of salt converted to insoluble salts by treated the water with lime soda. Now, here you'll take one water, that is hard water. Suppose that water contains calcium chloride. this hot water, this calcium chloride react with sodium carbonate Na2CO3. Now we'll get this is a hard water, calcium chloride, that is a hard water. This hard water is treated with sodium carbonate. Sodium carbonate. Now we'll get calcium carbonate plus NaCl. This type of reaction takes place during the lime soda process. Okay, here the calcium chloride is present in the water, that is a soluble form. The soluble form of this salt is treated with lime soda and converted to insoluble form of salt. This insoluble form of salt, that is calcium carbonate, the calcium carbonate is settled down in the water, and this precipitate, the insoluble precipitate can be easily removed, or can be easily removed by filtration process. Okay, this process is called lime soda process. Okay, and next we will discuss about the second process in the external treatment, that is zeolite process. Zeolite process. Zeolite process, or otherwise is called as permutate process. Permutate process. Zeolite process or permutate process. What is zeolite? Zeolite, that is hydrated sodium aluminosilicate. The chemical formula for the zeolite, hydrated. What is the chemical name for zeolite? Hydrated sodium aluminosilicate. Sodium aluminosilicate. This is the chemical name. And the chemical formula for zeolite, that is Na2O, Al2O3, X, SiO2, and YH2O. X ranges from 2 to 6 and Y ranges from 2 to 10. This is zeolite. And next one is the types of zeolite. Types of zeolite. There are two types of zeolite. One is the natural zeolite, and another one is the synthetic zeolite. Synthetic zeolite. There are two types of zeolite. Natural zeolite. What is natural zeolite mean? Natural zeolite, that is green sand, and non-porous in nature. Non-porous nature. But synthetic zeolite, that is jelly-like. Synthetic zeolite, that is gel formation and then porous in nature. Porous in nature. Out of these two types of zeolite, which one is mostly used in the water softening process means synthetic zeolite, that is used for the softening of water. Because the synthetic zeolite, it contains a porous substances, porous nature, because this pores, it absorbs the unwanted impurities present in the water. Okay, this synthetic zeolite is simply represented as Na2Ze. Na2Ze, that is a sodium zeolite. This in the sodium is loosely bonded with the sodium. It is loosely bonded with zeolite frame. So the sodium ion can be easily replaced. By using calcium and magnesium hardness causing substances. Okay, this sodium can be easily replaced from zeolite framework by using calcium and magnesium salts present in the water. And next, now we see the process of zeolitic process. Here you'll take one column. Here you'll take one column. The column is fully packed with zeolite bed. This is a zeolite bed. And then inside the column, the hot water is supplied into the column. The zeolite bed, it absorbs all the cations from the hot water. And then the cation free water I will get from outside the column. This is a soft water. The zeolite bed, it absorbs only the cations like calcium and magnesium ions. These ions only absorbed by this process. Okay, the hot water, once again, I'll repeat the same process. The hot water is supplied into the column. The column is fully packed with zeolite. The help of that zeolite, it remove all the hardness causing cations, and then you'll get a soft water. Okay, now see the reaction during this process. First of all, here you'll take one hot water. The hot water is consists of calcium chloride. This is calcium chloride. And then this hot water is treated with sodium zeolite. Sodium zeolite. These two things react. Now will get sodium, calcium. The sodium ion can be easily replaced by calcium ions. So now we'll get calcium zeolite, CaZe plus NaCl. These types of reaction takes place during this process. Okay, calcium chloride, that is a hard water. The hard water, it contains calcium chloride salt. This salt is a hardness causing salt. This water is treated with sodium zeolite. These two things react. Now we'll get calcium zeolite plus sodium chloride. These types of reactions takes place during this process. And see the another example in the same process. Suppose that water containing magnesium chloride means this magnesium chloride, it react with sodium zeolite, Na2Ze, MgCl2, it react with Na2Ze. Now we'll get MgZe plus NaCl. Na2Ze, Na2Ze. These two things react. Now we'll get MgZe plus NaCl. This is another example for the same process. But this process is taking place continuously. At one stage, the zeolite bed, it losing its absorption capacity because all the impurities, it block the pores of the zeolite bed. And then now supply the now supply the hot water. Now stop the supply of hot water. Now regenerate. Now regenerate this zeolite bed with the help of sodium chloride. And next now we'll see the regeneration process in the same thing. The zeolite bed can be regenerated with the help of sodium chloride. With the help of sodium chloride. With the help of the sodium chloride, the bed can be regenerated. The zeolitic bed can be regenerated. Now see the reaction, that is calcium zeolite. This is calcium zeolite. This calcium zeolite, the zeolite bed, it absorbs all the cations from the water. And this is the calcium zeolite. The calcium zeolite that is treated with sodium chloride. Sodium chloride now will get sodium zeolite plus calcium chloride. These types of reaction takes place during this process. Okay, up to this all of you understand? Okay, and next now we'll see the third method in the external treatment, that is ion exchange process. Ion exchange process. In this process, the hard water is converted to soft water because all the hardness causing substances it absorbed by the ion exchange resin with the help of ion exchange resin. In this method, to remove all the hardness causing cations and then anions. Cations like calcium, calcium and magnesium, and anions like chloride, sulfate, and bicarbonate. All these anions and cations can be absorbed with the help of the ion exchange resin. Okay, and then what is ion exchange resin? Ion exchange resin, that is um, long chain. That is the resin that is long chain and crossly linked and then polymeric substances. There are two types of resin. One is the cation cation exchange resin, and another one is the anion anion exchange resin. What is cation exchange resin mean? The cation exchange resin, the general formula for cation exchange resin, that is RH2. This is called cation exchange resin. The representation of cation exchange resin, that is RH2. That is, the resin is treated with acid. Now we'll get cation exchange resin. The general formula for cation exchange resin, that is RH2. Okay. That is, with the help of this RH2, to remove all the cations present in the water. The cations like calcium, Ca2 plus ions, and then Mg. All these ions can be easily removed from the water. And then next one is the anion exchange resin. The anion exchange resin can be easily represented as anion exchange resin. Anion exchange resin can be easily represented as R dash R dash OH twice. This is called anion exchange resin. With the help of this anion exchange resin, it remove all the anions like Cl minus and then SO4, SO42 minus, etc. The example for cation exchange resin, that is sulfonated coal is the example for cation exchange resin, and then anion exchange resin, the example for anion exchange resin, that is urea formaldehyde, this is the example for anion exchange resin. And next thing, the commercial name for cation exchange resin, that is Davex, Davex, Davex 50. And then anion exchange resin, the commercial name for anion exchange resin, that is Davex 3. Davex here, Davex 50, and then Davex 50. And then in the same way, anion exchange resin, the commercial name for anion exchange resin, that is Davex 3. And next now we'll see the process in the ion exchange resin. Here, we'll take two columns. Two columns. Here we'll take two columns. The first column, here we'll take two columns. The first column is filled with here we'll take two columns. The first column is filled with cation exchange resin. The second column is filled with anion exchange resin. Here it filled with anion exchange resin. Now the hot water, now the hot water is sent into the first column. Here, with the help of this cation exchange resin, all the cations from the hot water, it absorb all the hardness causing substances. With the help of the cation exchange resin, it absorb all the cations from the hot water. And then the cation free water is sent into the second column. Here, the anion exchange resin is packed in the second column. The anion exchange resin, it absorb all the anions from the hot water, and then we'll get a soft water. This process is going on continuously. Once again, I'll repeat it. Here there are two columns. The first column is filled with cation exchange resin, and then second column is filled with anion exchange resin. The cation exchange resin, now the hot water is supplied into the first column. The first column, it contains cation exchange resin. The cation exchange resin, it absorb all the cations from the hot water, and then the cation free water is sent into the second column. In the second column is fully packed with anion exchange resin. This anion resin, it absorbs all the anions from the water, and then you will get a pure form of water. That water is a soft water or deionized water or demineralized water. Okay, this process is continuously taking place. Now we'll get a soft water. During this process, the reaction takes place. In the cation exchange resin, these types of reaction takes place. That is, what is the general formula for cation exchange resin? RH2. RH2. This is cation exchange resin. This cation exchange resin, it react with hot water. Suppose that hot water, it contain calcium chloride. Calcium chloride. These two things react. Now we'll get these two things react. Now we'll get RCA plus 2HCl. These types of reaction takes place. This is cation exchange resin. This is a general formula for cation exchange resin, that is RH2. RH2 reacted with or treated with hot water. Suppose that water contain the hardness causing substances like calcium chloride. These two things react. Now we'll get RCA plus 2HCl. These types of reaction, this type of reaction takes place in the cation exchange resin. In the same way, the second column containing anion exchange resin. What is the general formula for anion exchange resin? R dash OH twice. This is anion exchange resin. This anion exchange resin is treated with HCl. Is treated with HCl. Now we'll get R dash Cl2 plus H2O. This type of reactions takes place during the anion exchange resin. Here, all the anions like Cl minus ions, it absorb the anion exchange resin, and then we'll get a pure form of water. But the resultant water free from all types of ions. Cation exchange resin, with the help of cation exchange resin, it absorb all the cations like calcium Ca2 plus ions and magnesium 2 plus ion. And in the same way, anion exchange resin, it absorb all the anions like Cl minus ions, SO4 2 minus ions, and then bicarbonate ions, etc. In that way, you will get a pure form of water. You will get a water. That water is a deionized water, or free from all types of ions. The process taking place continuously. At one stage, these two resins, the cation exchange resin and then anion exchange resin, it losing its absorption capacity, because all the pores, the cation exchange resin pores and also the anion exchange resin pores, is blocked by the hardness causing substances. But next, now we'll start the regeneration process. In the regeneration process, the cation exchange resins can be regenerated with the help of HCl, and the anion exchange resins can be regenerated with the help of sodium hydroxide. Okay, cation exchange resin. Regeneration. Cation exchange resin is regenerated with the help of HCl, and then anion exchange resin can be regenerated with the help of sodium hydroxide. with the help of sodium hydroxide. Next, now we'll see the reaction. This type of reaction takes place in the cation exchange resin, that is RCA, that is cation exchange resin. This is a cation absorbed resin. This absorbed resin, it reacted with HCl. It reacted with HCl. Now we'll get RH2 plus CaCl2. These types of reaction takes place during the regeneration process in the cation exchange resin. In the same way, anion exchange resin can also be regenerated. That is R-Cl2. This is anion absorbed resin. This anion absorbed resin is treated with sodium hydroxide. Sodium hydroxide. These two things react. Now we'll get R dash OH twice plus NaCl. These types of reactions takes place during the regeneration process. Up to this, are you clear? And next thing, now see the advantages. The advantages of ion exchange process, it can be used for water used in the high pressure boiler, and then it can treat highly acidic and then alkaline water. And the disadvantages, that is, it is more expensive, and iron and manganese cannot be removed as they form complexes with resin. These are the some disadvantages in this process. Okay, and next now we'll see the next process, that is next process, that is desalination. Next now we'll see the process of internal method. There are two softening method. One is a external treatment and another one is a internal treatment. Internal process. What is internal process mean? The residual salts that are removed by external methods. That residual salts can be removed by using some chemical compounds. These compounds directly added inside the boiler. In that way only you have removed all the residual impurities. Okay, what is internal treatment mean? Internal treatment, here we have used some chemicals. That chemicals is directly added inside the equipment or inside the boiler. In that way, you have removed the remaining residual substances. That is called internal treatment. Okay, the chemicals used in that process, that is known as boiler compounds. Okay, there are various methods, there are various internal treatment methods. That is, one is carbonate conditioning. One is carbonate conditioning, and another one is second one is phosphate conditioning, and then third one is chalcone conditioning. And then fourth one is sodium aluminate conditioning. These are the four internal methods. They are carbonate conditioning, phosphate conditioning, calcon conditioning, and sodium aluminate conditioning. Okay, now we'll discuss one by one. Okay, once again, I'll repeat it. What is internal treatment process mean? Internal treatment process here, still that after the external treatment, in that water, it contains some uh, hardness causing salts. The hardness causing salt can be removed by adding some chemicals directly inside the boiler. That is called internal treatment process. In that process, here we are using some chemicals. That chemicals are called boiler compounds. There are various methods in the internal treatment process. That is carbonate process, phosphate conditioning or carbonate phosphate process, calcon process, and then sodium aluminate process. Okay, now we'll discuss one by one. In all the process in general, the internal treatment methods are followed by blow down operation. What is blow down operation mean? By frequently supply the fresh water. In that way, you can remove all the impurities present in the water. That is called blow down process or blow down operation. Okay, now we'll see one by one. Now we'll see this internal treatment method. First one is a carbonate conditioning or carbonate process. In the carbonate conditioning, the carbonate conditioning, it is mainly used in the low pressure boiler. Here, the carbonate salts like calcium carbonate is used for the carbonate conditioning process. The calcium carbonate that is treated with hard water. The calcium carbonate salts is treated with hard water. The hard water, it contains calcium sulfate salts or magnesium chloride salts or calcium chloride salts or magnesium sulfate. These are all soluble salt. The soluble salt is converted into insoluble precipitate. That insoluble precipitate can be easily removed by some other process. That is here we are using one process. That process name is called blow down process. Okay, that is this process, this carbonate conditioning, it is mainly used in the low pressure boiler. And next thing, now see the reaction. Here, we'll take a water. Suppose that water contain calcium sulfate. That calcium sulfate is treated with sodium carbonate. Sodium carbonate, CaSO4, that is a hard water. That hard water contain the calcium sulfate salts. That water is react with sodium carbonate. Sorry, calcium carbonate. Sorry, sodium carbonate. These two things react. Now we'll get calcium carbonate plus sodium sulfate. Okay, this type of reaction takes place during this process. Once again, I'll repeat it. Carbonate conditioning. Carbonate conditioning, it is mainly used in the low pressure boiler. Here we have used some carbonate salts like sodium carbonate salt is used. That sodium carbonate salt is treated with hard water. Suppose that water contains calcium sulfate. These two things react. Now we'll get calcium carbonate and sodium sulfate. Okay, this calcium carbonate, that is a insoluble precipitate. That insoluble precipitate can be easily removed from the water by using blow down operations. And next one is a phosphate conditioning. The second process in the internal treatment, that is phosphate conditioning. The phosphate salts like sodium phosphates are used for this type of process. This process, the phosphate process, is mainly used in the high pressure boiler. Suppose here you'll take a hard water. That water, it contains calcium sulfate. This calcium sulfate, it react with sodium phosphate. Na3PO4. These two things react. Now we'll get calcium phosphate Ca3PO4 PO4 twice plus Na2SO4. This type of reaction takes place. There are three types of phosphate salt. One is a sodium phosphate. Another one is a disodium uh, hydrogen phosphate. And another one is a sodium monosodium dihydrogen phosphate. Okay, one is a sodium phosphate Na3PO4. Another one is a disodium Na2 Na2HPO4, and then another one is a NaH2 NaH2P4. There are three types of sodium phosphate salt. One is trisodium phosphate. Another one is a disodium monohydrogen phosphate. Another one is a monosodium dihydrogen phosphates. Okay, these three types of phosphate salt is used for it is used for treating the water. First one is a trisodium phosphate salts. It is mainly used in the highly acidic water. And then hydrogen phosphate salt. It is mainly used in the highly slightly acidic water. And then monosodium dihydrogen phosphate, it is mainly used in the highly alkaline water. Based upon the nature of the phosphate salt, that water can be used for the what type of water, highly acidic or slightly acidic or highly alkaline water. Okay, and then third process, that is Calcon treatment. What is Calcon mean? Calcon, that is one complex nature substances. What is the chemical formula for Calcon? That is sodium hexametaphosphate. Sodium hexameta sodium hexametaphosphate. The formula for sodium hexametaphosphate, that is Na2 Na4 Na4 Na2 Na4 P. Sodium hexametaphosphate, the formula for sodium hexametaphosphate, that is Na2 Na4 PO3 6 times. That is sodium hexametaphosphate. Now see the reaction. The sodium hexametaphosphate is treated with hard water. Hard water. It forms a soluble precipitate. So there is no problem for sludge disposal. It is used for both high pressure and then low pressure boiler. Okay, now see the reaction. Here you'll take the water, that is hot water. That water, it contains CaSO4. CaSO4. This is hot water. This hot water is treated with this hot water is treated with sodium metaphosphate, that is calcon, Na, Na2, Na4, PO3 6 times. This is calcon. These two things react. Now we'll get Na2, Na2, Ca2, PO3, six times. Okay. The calcon conditioning, because of this reason, that is this process, there is no sludge formation, and then this process is mainly used in both high pressure boiler and low pressure boiler. Because of this reason, the calcon conditioning is better than phosphate conditioning. And then last process, the last conditioning process in the internal treatment, sodium aluminate conditioning. Sodium aluminate, what is the formula for sodium aluminate? That is NaAlO2. Sodium aluminate conditioning, that is NaAlO2. This is a formula for sodium aluminate. In this process, the sodium aluminate is first undergo the hydrolysis in the boiler water to give a gelatinous white precipitate of aluminum hydroxide and sodium hydroxide. Now see the reaction, that is sodium aluminate NaAlO2, it undergo the hydrolysis process. Now we'll get aluminum hydroxide aluminum hydroxide plus sodium hydroxide. In the second stage, this sodium hydroxide then react with magnesium salt present in that water. Now we'll get magnesium hydroxide. The sodium hydroxide react with magnesium salt. This magnesium salt is present in the water. Suppose here magnesium chloride is present. These two things react. Now we'll get magnesium hydroxide plus NaCl. These types of reactions takes place during this process. The gelatinous precipitate of aluminum hydroxide and then magnesium hydroxide, it attract all the impurities present in the water. In that way, you have removed all the impurities from the water. Finally, the precipitate can be removed by blow down process or blow down method. Okay, this is called internal treatment. Okay, once again, I'll repeat it. What is internal treatment mean? Internal treatment, that is a substances adding inside the boiler after the external treatment. Here we have using some chemical compound. That compound name is called boiler compound. And then in the internal conditioning, there are various methods. One is a carbonate conditioning, another one is a phosphate conditioning, and next one is a calcon conditioning, and next one is a sodium aluminate conditioning. In carbonate conditioning, here we are using carbonate salts like sodium carbonate is used. This carbonate conditioning, it is mainly used in the low pressure boiler. But this hot water is treated with carbonate salts, that is sodium carbonate salt. Here you will get a insoluble precipitate, that is calcium carbonate. That calcium carbonate can be easily removed by blow down process. And next one is a phosphate conditioning. Here in the phosphate conditioning, it is mainly used in the high pressure boiler. Here we are using one phosphate salts like sodium phosphate. That sodium phosphate salt is treated with hot water. Now we'll get a calcium phosphate salt. The calcium phosphate salt can be easily removed by blow down process. In the phosphate conditioning, there are three types of phosphate salts. Three types of phosphate salt. That is, one is a sodium trisodium phosphate, another one is a disodium monohydrogen phosphate, another one is a monosodium dihydrogen phosphate. That is, the various types of salt can be used in the various types of water. First one is a trisodium phosphate salts, mainly used in the highly acidic salts, and then disodium monohydrogen phosphate is mainly used in the slightly acidic water. And next one is a disodium monohydrogen phosphate, that is monosodium dihydrogen phosphate is mainly used in the highly alkaline water. And then third method in the internal treatment, that is calcon conditioning. Calcon conditioning, that is a calcon. What is the naming of the chemical name of the calcon mean? That is sodium hexametaphosphate. That is, what is the formula for sodium hexametaphosphate? Na2Na4PO3 6 times. Here, this calcon is treated with hard water. Now we'll get a complex formation. There is in this method, in this calcon method, the final precipitate, that is a soluble precipitate, there is no problem for sludge disposal. But all other methods, the sludge can be formed, that is precipitate can be formed. That precipitate can be easily removed by blow down process. So because of this reason only, the calcon conditioning is better than phosphate conditioning. And the last one is the sodium aluminate conditioning. Sodium aluminate conditioning, that is another last process in the internal treatment. That is, what is the formula for sodium aluminate? NaAlO2. Sodium aluminate is treated with first it undergo the hydrolysis process. During this hydrolysis process, it forms sodium hydroxide and magnesium hydroxide. And then in the second stage, the sodium hydroxide is again react with water. The water containing some magnesium salts like magnesium chloride. These two things, the sodium hydroxide and magnesium chloride, it react. Now we'll get magnesium hydroxide. This magnesium hydroxide and aluminum hydroxide, that is a gelatinous precipitate. That gelatinous precipitate, it entrap or it absorb or it catches the impurities present in the water. Okay, and then finally it form a precipitate. This precipitate can be easily removed by blow down process. Okay, and then what is the what are the differences? And finally, we will discuss about what are the differences between external treatment and internal treatment mean. In the external treatment, what is external treatment mean? External treatment, that is outside the process takes place outside. Before the water is fed in the boiler, the water is treated with externally. That is called external treatment. Internal treatment mean the water is treated internally by adding some chemicals inside the boiler. That is called internal treatment. And next one, in the external treatment, there are three process. One is a lime soda process, another one is a zeolite process, and last one is a demineralization or ion exchange process. In the internal treatment, there are four methods. One is a carbonate conditioning, another one is a phosphate conditioning, another one is a chalcone conditioning, and next one is a sodium aluminate conditioning. And next one is in the external treatment, it is a preventive method. Preventive method means it reduces the scale formation, or it reduces the boiler trouble. Boiler troubles like scale and sludge formation, caustic embrittlement, boiler corrosion. These are all the various troubles arises due to the presence of hardness causing substances. And next one is internal conditioning. It is a corrective method. And then external conditioning, it is frequently used in the high pressure boiler, and then internal conditioning is frequently used in the low pressure boiler. These are all the some differences between external conditioning and then internal conditioning. Okay, that's all. Thank you very much.